Welcome back after our little break. This is Anthony Priscilla continuing our discussion of logarithms where we left off. Today we're going to start off using our calculators to evaluate some logarithms. And there are two logarithm keys on most calculators. There's the common logarithm, which is just log. And if you see log without a base data, we assume it's base 10. The other logarithm key you'll see on your calculator is the ln. That's the natural logarithm function. It looks like in, but most calculators write it with a capital L and a capital N. One thing I should mention is when you're typing these logarithms, these messy expressions into MyMathLab, don't ever hit any spaces. If you're punching in the right answer, it'll space it the way it needs to be. So don't hit a space key anytime. There are two different general types of calculators. There's the graphing calculators and those that use the straightforward notation. And then there's also the traditional calculators that aren't graphing, that use a reverse notation. Here's a classic example of one that uses the reverse notation, the TI-30XA. I'm going to do this problem with both types of calculators. To do it with the TI-30XA, turn it on. I know there might be a glare there. And with this type of calculator, it's a reverse notation. You don't hit log and then 22. You enter 22 and then hit log. And we're told to round this to 4 decimal places. So the answer would be 1.342, and then it's a 4-2, so just 1.3424. I'm not sure how good it shows there. There might be a bit of a glare out there for those of you sitting out there in the classroom. If we use a graphing calculator for this, let me clear all of that. You're going to use a straightforward notation. By that I mean you enter it the way it's written. You hit log and then 22. And let's get into the habit of closing the parentheses. Notice how it opened parentheses, so let's close them. And it's the same answer, 1.34242. So we'd round that to 1.3424. The next thing we're going to do, you're thinking, well, wait, there's only two logarithm keys on your calculator, log base 10 and that natural logarithm function log base e. How the heck do we punch something like log base 3 into a calculator? Well, that's the change of base theorem. Change of base. And it says this, log base b of x equals, and you can use either one of your keys on your calculator, either the common log, log x over log b, or you can use the ln key if you want. Just don't mix it. As long as you're consistent, you'll get the correct answer. Just can't mix it. So with something like log base 3 of 7, if we want to use the log key, you'd go log, and then the number, you've got to remember which one goes above and which one goes below. Well, the number that's up on top is the one that's written higher. Notice how the base is a subscript, so it's written lower. That's the one that goes on the bottom. So it's a matter of now punching this in, and I'll do it with both calculators. First, that little let's see. Wondering, can you see that? First, the reverse notation. It's going in reverse. You don't hit log 7. You go 7 log divided by 3 log. And notice how, if you can see the screen here, I'm not sure if you can, because of the glare, it's calculating as it goes. It might be tempting to think that's the answer, but no, you still got to hit equals. 1.7712437449. I've just written it down. I'm not sure how it told us to round it. We'll see that in a moment, how we round it. Once again, to enter log 7 over log 3, but this little reverse notation calculator, you go, let me try it like this. 7 log divided by 3 log equals. With the graphing calculator, pretty much enter it the way it's written, but you must pay close attention to the exponents. Excuse me, to the parentheses. Log 7. Notice the way those parentheses open, so you need to close them. Divided by log 3. Get into the habit of closing the parentheses. Enter. Same number. We were told on this problem to round our answer to 4 decimal places. And so log base 3 of 7, 1.771. So this 2 here, do we leave it as a 2 or make it into a 3? Well, we leave it as a 2. If the digit after it is a 5 or larger, you round up. Otherwise, you just drop everything after it. 1.7712. And then another one like this. I'll do it with the graphing calculator first. It is, okay, I'm going to punch in log 0.56 divided by log 9. Notice how I close those parentheses. You gotta be sure to close them. Negative 0.26388. Negative 0.26388. It goes on and on, but we're told to round this to 4 decimal places. So negative 0.2639. Let's try pitching this into a calculator with that does the reverse notation. I want this little traditional calculator to punch in. Here's what I'm punching in. It would be log 0.56 over log 9. So I'm doing this change of base, punching in log 0.56 over log 9 with this little traditional calculator. You got to do it in reverse. You punch in the number 0.56 log divided by 9 log, and it's tempting not to hit equals. You got to remember to hit equals. Equals negative 0.2639. Same answer. Once again, you punch in 0.56 log divided by 9 log equals. Now, we've already stated that logarithmic functions and exponential functions are inverses. So, we stated rules like this. B to the log of base b of x equals x. If you have the same number here and here, those cancel out. And also log base b of b to the x is x, provided you have the same number. Now, ln means log base e. So if we just replace all of these b's with e's, whenever we have log base e, we're going to write ln. So this gives us, let me write it in a different color. Replacing the b with an e. E to the ln x equals x. E and ln, when they're side by side like that, cancel each other out, you could say informally. Also, log base e, that's ln e to the x equals x. So e and ln, when they're side by side, cancel each other out. That's how we're going to wrap up this assignment here. Problems 14 and 15 are going to use that. So let's see. This is problem number 14. Are y'all caught up? I know I'm going through this quickly. Any questions there? No? Y'all are my silent class today, aren't you? Number 14. Let me see. Let me zoom in a little more because I'm not using my calculator here. Sort of had to have it zoomed out. There. Okay. It says g of x is e to the x, find g of ln 9. Well, whatever's inside the parentheses, you plug that in for x. So this would be e to the ln 9. E and ln cancel out, leaving you just a 9. And then, as luck would have it, as I'm printing this out, of course it's going to generate that problem that looks very much like the one we just did. This ln 3 squared, would that 3 squared just be a 9? I'm thinking it's going to give us the same thing. We'd have an e. Whatever's inside these, you plug in for x. So it'd be a ln 3 squared, which would still just be a 9. Fortunately, part C, now, more than likely, yours won't have the same number regenerated there. Okay? Now, in part C, plug all of this in for x. We have an e. And in place of this x, I write ln 1 over e to the 5th. The e and ln cancel out, leaving 1 over e to the 5th. Now on problem number 15, it's very similar. Let me move it up. Given f of x equals ln x, find all of these. Well, whatever's inside these parentheses, we're plugging in for x. So we're going to have an ln, and in place of the x, e to the negative 3rd. The e and ln, when they're side by side like that, cancel out. So we have a negative 3. Next, on part B, there's a couple of ways you could do this. Right off, you could cancel this E and that ln, or if you just want to make it look messy, you can plug all of this in for x, so we'd have that black ln. Let me see if I can color code it. So we have that black ln right there, and then all of this stuff right here I'll write in red. E to the ln 3. So sort of how you want to cancel is going to be up to you. You can cancel the black ln with the red e, or if you want to cancel the red e and red ln, you're still going to be left with a ln. If you cancel those, you'll have the red ln and a 3. If you cancel these, you'll have the black ln and the red 3. But the color doesn't really matter. I'm just going to write ln 3 in blue. And on C, same thing. Plug that stuff into parentheses in for x, so we have a black ln, and in place of that x, we have all of this, e to the 2 ln 3. Now notice here you can't cancel the red e and the red ln, because they're not side by side. Something's between them, that number 2. So here we cancel those, and we're left with 2 ln 3. So, let me see. Thinking that's it. That's it for this assignment. So, we will take a break right now, and then we got to discuss the next topic, solving exponential equations and logarithmic equations. We've already solved some exponential equations by getting the common base on both sides. What if what we have isn't a common base, doesn't have a common base? Then we'll be able to use logarithms. So in that section, you're going to have to be really familiar with your calculator, how to punch some stuff in. And so whatever type of calculator you're using, you're going to need to practice with it. And it's these reverse notation calculators that are a little bit trickier punching in for some of the stuff. Okay? So we'll take a break and we'll continue in a little bit.